we said last week that there are 3 concentration units that you have to know. And all concentration units have 2 parts, 2 measurements. Okay? Concentration units. Have 2 parts. All concentration units have 2 parts. Okay? You're going to have some kind of measurement of the amount of solute in a fraction such that this is the numerator. And the denominator is going to be either a measurement of the amount of solvent or solution. Okay? Every concentration unit always has some kind of measurement for the amount of solute and has some kind of measurement for the amount of solvent or some kind of measurement for the amount of solution. And you need to remember that the solvent amount plus the solute amount gives you the solution amount. I'm going to put a little star here because there is an exception to that. Okay? Solvent amount plus solute amount is the solution amount. Okay? That is not entirely always true. Okay? It doesn't apply to volumes. Alright? Let me explain why. Very briefly. Water molecules have this hydrogen bonding thing that goes on. That makes water molecules slightly spread out from each other. Okay, water molecules have hydrogen bonding going on between them, and it makes water molecules slightly spread out from each other. When I put a salt like sodium chloride, which has small ions in a salt like sodium chloride tend to fit in the spaces between those spread out water molecules. Okay, the result is that as long as the concentration of table salt is low, you can actually decrease the volume of water by adding salt to it. Okay, now that's not something you have to know for chemistry, but that's why volume doesn't work when we're talking about that. There's particle interaction we can't account for with volumes. Okay? So over there, when we're making our saturated solutions of magnesium sulfate and sodium chloride and calcium chloride, we kept having to take water out, our solution out of the magnesium sulfate, but we never took any water out of the sodium chloride because no matter how much salt we put in there, it never overflowed because it kept fitting in the spaces between the water molecules. Okay? Which is really cool when you think about it. Okay? All right. So let's look at our concentration units then once again. We have molality, which is a small letter M. Okay, this is molality. M-O-L-A-L-I-T-Y. And molality is moles of solute over kilograms of solvent. Okay? Then we've got capital M with a line under it. And that's molarity. Alright? That's moles of solute over liters of solution. SOLN is a shorthand way of writing solution. Now, molality is often also stated as molar concentration. Molar or molar concentration. Okay? I'm sorry, that's molal. That should be an L there. I've got mole concentration. And molarity is molar concentration, or simply molar. Okay?
Mr. Taylor, what's after L?
After this, SOLN is a shorthand way of writing the word solution.
That's the what is it?
SOLN. And then the last one you need to know about is percent concentration, or simply percent. And that is mass of solute over the same mass units of solution times 100. So the units of measurement have to match for both solute and solution here for percent concentration. Couple things to remember. If you're going to convert between mass and moles, what do you need to do? What do you have to find? Molar mass. You have to find the molar mass for the conversion unit. Okay? If you're going to convert between grams and kilograms, what do you need to know? What the ratio is, and that's that there are 1,000 grams in 1 kilogram. What if you're going to go from milliliters to liters or back again? It's 1,000 milliliters in 1 liter. Unit 1, the milliprefix. The milliprefix. M is milli. Okay? Is 1,000th of whatever the base unit is. And the K, or kilo prefix, means 1,000 times the base unit.